Today I will discuss the rate of reaction, like about the rate. What we're basically discussing about the rate of reaction, we firstly discuss about the chemical kinetics, because this is a part of chemical kinetics. With chemical kinetics. In chemical kinetics, we basically discuss about the rate of reaction, the mechanism of reaction, and the factor affecting the reaction. The factors affecting the reactions. Factors affecting the reactions. Right? So there are some factors that we discuss in chemical kinetics. Now, what is rate of reaction? Rate of reaction is basically changing concentration of reactant or product with the passage of time or with the time. So rate of reaction is basically equals to rate of reaction. Let's take another marker with the brightness so that I can write it easily. So rate of reaction is basically equals to concentration of reactant or a product with respect to time. Concentration of reactant with respect to time. Okay. If we talk about reactant and product, there are basically two types of species that we're going to discuss here. The first is the reactant and product. So rate of reaction depends on the concentration of reactant or product with factor, which is time, right? Or time, right? Something like this. Let me show you. Rate of reaction. Okay, let's take another marker with dark here so that it will be prominent. So I can say that the rate of reaction, let's just take it. Rate of reaction is equals to concentration of the reactant with the passage of time, right? So this is basically we discuss rate of reaction. Let's talk about the types of reaction that we usually experience in a daily life, right? So let's not a daily life with examples of reactions. So let's do it. Okay, so let's discuss it. Everything is known. So yeah. So basically we know that I can erase this to start. So types of reactions. If we talk about the first reaction is basically a very fast reaction, right? Very fast reactions. For example, for a very fast reaction, we can take, for example, a silver nitrate, KgNO3, combines with NaCl to give, it gives AgCl2, which means AgCl, which means silver chloride, AgCl plus NaNO3, sodium nitrate. Actually, this is a very fast reaction. It gets done in an instant of time. Like, it does not take a much time to perform it, because well, one thing that we need to discuss here is that it is already present in form of ion. For example, this is present in form of time, Ag plus 2 minus 3, Na plus 1 minus 1. So they are already present in form of ion. It does not take time to break the bond and to make with other species. So it does not take time. If we talk about other hand, very slow reactions, let's just write it. Very slow reactions. Then we can talk here is that the first very slow reaction that we counter is, for example, the rusting of iron. It takes ages, let me show you the picture of rusting of iron because it takes ages to complete this reaction. Rusting of iron, it takes ages and a very slow reaction. You cannot find the rate of reaction of such reaction because it takes a very long to get done. Let's research here, get in GIF, so that will be very easy for you to understand it. No GIF here, so we can discuss it through it. Let's see here. Let's just bring this picture here. As you can see, the rusting of iron. This is basically a rusting of iron when the iron reacts with oxygen from the surrounding from. So you can see it takes ages to get done, and you cannot find the rate of reaction of such reactions. But if I talk about the formation of ammonia, for example, now we talk about the intermediate reactions. So it takes time to get done, the intermediate reactions, or the moderate reaction. I'm only discussing one reaction, that's why I've added the, but you can discuss a lot of them with the moderate reactions, right? So let's discuss the moderate reaction. For example, formation of ammonia into, you can balance this equation by yourself, plus H2 is equals to NH, okay, it's getting more, NH3, formation of ammonia. Let's just discuss how this ammonia form bond. So let's erase it, and I'm going to discuss here that how ammonia form bond. So first of all, nitrogen, which is double bonding, something like this. This is nitrogen with the triple bond attached with the other nitrogen, and then hydrogen. So it takes a while to break the bond and to make with hydrogen. It takes time, right? As you can see, a covalent bond is there, and it takes time to break the bond and to make with other. And after the formation, it will bond something like this with one lone pair, H, and yet again H. This is basically ammonia, so it takes time to move on, right? So that's why it's an intermediate reaction, right? Now we're going to talk about the two types of reaction. One is instant reaction, what other one is what other one we're going to discuss here is average reaction. So let's discuss it. Let me just erase that so we can discuss other reaction. So oh my god, it's too cool. So let's do it. Types of reactions. I think it's clear, so let's just erase it to type of reactions. Okay, let's take this first. Okay, the first is average reaction. Average reaction is basically a reaction that we find between 2 points. For example, it's just an example to take it for granted. So for example, this is one point, this is another point. Concentration at here, for example, this is a concentration of A at a point T, in a time T. Okay, in a time T. Then this is the concentration of A at a point 1, at a time T1, right? Concentration of A at a point T is equals to 1. So as you can see here, the concentration is different 2 points. So we in average reaction, we find concentration between 2 points, something like this. We find concentration between 2 points. Okay. For example, there's a reaction which is given something like this. So let's just write it. It is 2A plus 3B. 2A plus 3B is equals to C. 2A plus 3B is equals to C. How we can write average rate of reaction? So this is basically a way of writing rate of average rate of reaction. Actually, this is written something like this. That minus 1 upon 2. What does mean by minus? Actually, reaction here is getting with the passage of time, it changes into product. So it gets a negative charge. Just because the concentration of the reactant decreases, but the concentration of its product increases, right? That's why we include the negative sign here. For example, minus 1 upon 3B, concentration of B, and I forgot to just. So it's equals to, let's just erase it. It changes into I'm doing this. 1 upon song 1 is equal to song 1 is equal to concentration of C. Product is positive because the reacting changing into product. So this is a basic way of writing it. And if you want to talk about the basic, then I'm going to tell you that what does it actually mean, this bracket and this A written inside it. So let's discuss it. Okay. Let's take it. For example, this is basically A written inside this square bracket. So it basically means this is basically, if you want to talk about here something between 1 by 1, this is stoichiometric ratio. Let's just write with the help of this. This is stoichiometric coefficient, stoichio. I'm not writing complete, stoichiometric coefficient. And then if we talk about this shows the concentration of the reactant, concentration of the, I'm sorry, the concentration of the reactant. So rate of reaction shows something like this, that the rate of reaction is directly proportional. Rate of reaction is directly proportional to the concentration of A with passage of time. Concentration of A with the passage of time. It means it decreases or increases or something like that with the passage of time. This is basically an average rate of reaction. If we talk about an average rate of reaction, we discuss two things. The rate of appearance, appearance and rate of disappearance. In the rate of appearance, first of all, if we talk about the rate of appearance, we do not add it to stoichiometric coefficient. For example, the reaction is written something like this. For example, 3x plus 2y is equals to v, right? 2y, 3x plus 2y is equals to, for example, let us say 2x. So it's written something like this. But when we talk about the rate of reaction, the rate of appearance, we do not discuss the coefficient here. For example, it will be written something like this. The rate of reaction is equals to, this is about appearance, right? Keep in your mind. Exactly same with two modes. Actually, modes means everything positive. Even if you include a negative number inside this bracket, it turns into positive number. For example, I'm writing here this minus 2x. Right. For example, if there's something between minus 1 upon 1 is equals to concentration of, change in concentration of 2 x. This is, oh, what's happening here? Let's take a different marker to highlight it now. Okay. Changing concentration of x is like putting this bracket and change with time. So the value will turn into positive because of this mod turns the value into positive. So when I write rate of reaction is equal to change in concentration of reactant per unit time, and then it's positive. Same for the rate of disappearance. Rate of appearance we basically use for the product. Product means changing something that is getting increasement, something which we can show is appearance, right? So product and the rate of disappearance is exactly same, but that is for, we cannot use minus with product, but this is the only example to explain that why mode turns negative into positive. We talk about rate of disappearance for a while, consider it, so it's exactly same like this, right? So in the next video, we're going to talk about average rate of reaction with the graph.